Assalamu alaikum and welcome to another episode of mahauliyati mukalmay. Today we're joined by a very special guest, Hassaan Sipra. Hassaan Sipra is the director of the global engagement at the Alliance for Just Deliberation on Solar Geoengineering. He's a former consultant and senior researcher from ComSat's University in Islamabad. He's worked in the climate and environmental protection research and policy domains in several developing countries. Hassaan, thank you so much for being here with us.
Thank you. I'm glad to be here.
Today, we're talking about a really important issue, which is solar radiation modification. And in the past few years, especially after the 2023 UNEP emission gaps report, we found out that even with full implementation of the Paris Agreement, we're going to fall short of our goal to keep temperature below 1.5 degrees, and we're likely to reach or exceed 2 degrees Celsius. And because of that, conversations around solar radiation modification have come into sharper focus. So Hassaan, I want to ask you, because this is the area that you work on, what exactly is solar geoengineering and how does it fit into our climate response toolkit?
Yeah, thanks for that really great question, because it's so simple and yet it's a lot more confusing for people, because when they hear the term solar, we immediately sort of gravitate towards solar energy. And while solar energy plays a huge component in solar geoengineering, it's also called solar radiation modification, SRM for short. People generally make that confusion because they think about solar panels. And this is not the case. Solar geoengineering refers basically to a suite of technology options that would, in essence, reflect sunlight away from the planet, basically from the upper atmosphere generally, but also there are some options to do it from the lower atmosphere in order to reduce the amount of heat from the sun that the Earth is retaining under the greenhouse gas effect. So in essence, carbon dioxide, methane emissions, the major greenhouse gas emissions that we are sort of putting into the atmosphere, they have the quality of retaining heat onto the atmosphere and thereby warming the planet up. That's global warming. And so the conventional way to get around that would be to mitigate our emissions and basically not have those emissions be put into the atmosphere. But we're not doing that. We continue to surpass all records in terms of how we are emitting those gases. And so therefore, an alternative option that's been proposed that's more technology driven is that we just reflect sunlight away from the atmosphere by basically, generally, one strategy is to inject some reflective particles, aerosols, into the upper layer of the atmosphere, and therefore just reflecting that sunlight away, and then you're holding less sunlight onto the planet, and the global average temperature would drop. So that's at its very core the basic principles of solar radiation modification. So it's in the name, you're taking solar radiation and you're modifying the amount that's coming onto the planet.
Mm-hmm. And I think when you immediately hear of it, it does seem a little, I guess, dystopian, something you would watch in a sci-fi movie. It's not something that's really talked about very often in the general discourse among the public. So I want to know, I think everybody's immediate reaction would be to worry about the impacts of this. So where exactly are we with the science? How much do we know about the impacts, and where is the science research even taking place? Are there specific institutions or countries that are really leading research on this?
Yeah, I mean, I'm with you when you say that it seems very dystopian, particularly to the average person, because the way that these topics have always been presented to us as the general public is usually from a movie going or an entertainment perspective, right? So for a lot of people, The Matrix comes to mind, because that's where they basically were like, oh, the robots run on solar energy, so let's just block out the sun. And in essence, that really, I think for the vast majority of people, really digs to something deep into their core, which is that are we entering into a new domain? Are we basically infringing upon the domain of nature. And that's something that we should be upholding that value that nature has its own rights. And so from that perspective, I completely understand. And for what it's worth, these technologies are being brought to the fore in discussions simply because we're not doing what we're supposed to be doing when it comes to maintaining some semblance of that rights of nature, the domain of nature. And that's because we are, at this point, deliberately and very knowingly actually putting emissions into the atmosphere, which is already changing the climate in a way that it has never really been changed before. As to whether or not those technologies, like how we even know that this works, it's because of natural analogs. So there have been periods in history where the global average temperature has come down rather quickly. And it's been because we have seen large-scale volcanic eruptions. So the most recent example that's been quite well studied is Mount Pinatubo in the Philippines in 1991. Erupted, put out about 12 to 17 teragrams of sulfate aerosols, and then about 10 teragrams of that actually made it into the stratosphere, which is where we saw that it actually spread throughout the planet and kind of formed like what you would imagine like a reflective shield, and brought the global average temperature down by about half a degree Celsius for 1 to 2 years. So that is the natural analog for this idea that what if we just inject a smaller amount into the atmosphere and just reflect 1 to 2% of sunlight away. The problem with that entire process is less so the technical aspect, which there's this sense globally that technologically we could probably achieve it. You need to fly planes up to the stratosphere. We have planes that currently fly, which is about, let's say, 80,000 feet into the air, and we currently fly commercial planes at 45,000 feet. I think other military jets fly at about 55,000 feet. But we've had planes that have flown all the way up to 75,000 feet. The Bahadur base that in Pakistan that the U.S. government sort of used during the Cold War in, I think, 1960 to fly and do observations over USSR, flew at about 75,000 feet. So technologically, we are very much there. But there are massive challenges in terms of governance and in terms of knowledge about what the impacts are going to be. So clearly, we need to work through those. And the primary challenge is what would an injection like that do to other elements other than temperature? So what does it do to temperature at the regional level? How does that differ across regions? What does it do to precipitation? How would that impact agriculture? How would that impact water security, your socioeconomic security, and in particular then your geopolitical aspects as well? Those are all underexplored at this point. So that, I think, is the core problem. And the governance challenge then associated with that is that if a conversation about solar geoengineering needs to happen, then how do you make sure that the various parties, the various stakeholders across the planet, including global South countries and including vulnerable populations, how would they think about this issue and how would they respond to it, considering they're the ones most impacted by climate change? So without bringing them into the conversation and without making sure that they have the knowledge and the capacity to engage in this process, you're not really having that justice, the climate justice angle. You're not having inclusivity, transparency, and without all of those, this actually falls apart in terms of what would be considered the right way to do it.
Mm-hmm. So I want to to come to this topic of governance of SRM. And COP29 just passed. That was probably the ideal platform for you to have all of your stakeholders there and discuss this kind of a technology. And while it wasn't on the official agenda, I want to know what it was like on the ground at COP29, what kind of discussions were happening around solar geoengineering, and kind of what your takeaway from that is.
Yeah, I've been thinking about COP because I was very lucky this year to be able to go on the ground and participate in a few different events, see other speakers talk about solar geoengineering. And I walked away quite disappointed because at its core, the UNFCCC and the COP process is designed for global engagement and global consensus on climate change. And we are now at a point where the impacts of climate change are becoming much more apparent, and they are costing lives, they're costing ecosystems, and they are costing livelihoods as well. So the entire socioeconomic system and the biosphere are all in imminent danger at this point. We are about to cross 1.5 degrees Celsius. The WMO has said that we have on average crossed it this year. And so the risk levels are increasing. And despite that, despite the IPCC saying that roughly you need about $1.3 trillion per year in order to manage just the mitigation aspects, the deal that was struck between global North and global South countries was only $300 billion. And they had to fight tooth and nail to get it up from 250 to $300 billion. So the level of threat is exceptionally high, and the response to that level of threat is extremely muted. And so there's this massive disbalance in how we're actually engaging with COP, with climate change through UNFCCC and COPs. So that is why we're seeing more and more people starting to have this conversation more openly about solar geoengineering, is because the process that was put in place back in 1992 to deal with the problem has continued to fail because the global community has, for one reason or another, refused to take action at the level that action is required. And so when those SRM conversations are happening this year, I found that almost everybody who is having a conversation around solar geoengineering at COP talks about that mitigation must remain the priority while we consider this, because you can't have a conversation about solar geoengineering without also having a conversation about, well, how long is it going to take for us to actually get rid of all these emissions that we've already put in the atmosphere? And how long is it going to take us to actually take the greenhouse gases we've already got in the atmosphere and basically draw them down? Because a certain amount of warming is now already baked into the system, because we've already emitted much more than the system can actually sustain at the temperature that is safe for everybody. So my reflection is basically that the COP process, the UNFCCC process, is not at the level that it needs to be, and therefore SRM conversations are happening. And it's important that those SRM conversations take place that we quickly then ramp up efforts to make sure that those SRM conversations are taking place in a manner that is just and inclusive and transparent and within a global framework. Whether UNFCCC is the right place for that, I'm not sure. And I don't think that I should be the one to have to answer that question, because ultimately it would be a global decision. So we'll see whether or not that sort of idealistic viewpoint actually comes to pass. But certainly DSG is going to keep pushing for exactly that.
Mm-hmm. And I really like how you highlighted that financing gap that we have, and the lethargy from a lot of high emitting countries to stop what they're doing, but also to help countries most impacted by climate change deal with it and adapt to it. So I want to know a little bit more about the disparities that you see or have seen in your engagement with different nations. Are there clear forerunners in this race towards solar geoengineering? Which countries are really prepared to start talking about the governance challenges and the technology aspect of it?
That is the thing that probably haunts me the most, the disparity. Clearly, the forerunner in terms of research on solar geoengineering is the United States. A lot of papers have started to look at what we call the global north-south divide, and the US, UK, Germany seem to be clearly in the largest leadership position. And in terms of the global south, there is very little research. I think a rough estimate would that a lot of people sort of like cite anecdotally is that it's about 90% of all research on this is done in the global north, and that 99% of all funding, probably more than that actually, of all funding that has been dedicated towards solar geoengineering research work global north. So the gap is so wide that I think calling it a chasm is probably much more appropriate. And so within that context, then, how do you get global south countries to engage more effectively? Well, first and foremost, calling it the global north and the global south is also inaccurate because these are not monoliths. The global north has many, many actors who are less engaged in the process, though they may have more of an ability to engage on solar geoengineering activity and research. But it is the clear runners are the US, UK, Germany, and then you have many, many, many more, including Australia, France, and many others. In the global south, though, if you look at the top 25 countries that do solar geoengineering related research, it's China, India, and South Africa. There's a reason for that, because these countries have all got their own, in one way or another, are working on developing their own climate models, which is the primary way we sort of understand how climate change is occurring and how solar geoengineering might change the climate that we live in. So the global south is also not a monolith, and there's a lot more. There are a lot more people and a lot more communities around the world that need engagement. The primary way to do that is through funding support that builds and strengthens institutions in the global south to engage engineering from their own perspectives, rather than to have institutional knowledge developed in the US and Germany and the global north, and then sort of transferring those viewpoints over. Because the questions that vulnerable communities and nations may ask may be very different from the ones that are asked by their global north counterparts, because their lived experiences and the relationship they have with climate change is vastly different as well. And so it's important right from the outset to understand that even within research, you need governance. Even the kinds of questions that are being asked need to first be put within a framework of, is this even the right question? Is this question relevant for the entire global community? Is this question different from a question that somebody else somewhere else might be asking? And so good governance on SRM needs to begin early, and it needs to be in a manner that actually builds trust and legitimacy in how those questions were asked and how those questions were then investigated. So I think that would be a really good starting point, at least on solar geoengineering governance, both for the research and for actual decision making whenever we actually get to that point.
Mm-hmm. And I want to focus a little bit on Pakistan now. You've spoken to researchers and organizations within Pakistan about this issue. And what has their reaction been? What's their appetite for research or collaboration on solar geoengineering?
Yeah, really good question. Our DSG engagement with Pakistan has been quite long-lived overall because I mean, I'm from Pakistan. I lived and I worked in Pakistan at Comsats University. We had a Center for Climate Research and Development, and in end of 2018, beginning of 2019, this solar geoengineering issue was basically put forward to me by the head of our department, who said, "Hey, look into it." And my first reaction was very much what I think is a standard reaction, which is, "Oh, this is nuts. I don't think I want to touch this with a 10-foot pole." And with some, let's say, prodding from the head of my department, I looked into it a little bit more, and I was looking at more just how would one specific scenario of an injection in the stratosphere affect temperature and precipitation in Pakistan. And as I looked at the maps that were coming out, I was like, oh, so this does change the situation from what climate change is showing to do in Pakistan. And then that got me really concerned because I was like, if a lot more models and a lot more research starts showing that solar geoengineering might be an answer, then we get into even bigger problems. Number one, who is going to set the temperature of the planet, right? And number two, who is involved in that decision making? Where are you doing the injections? Because all of these various factors are going to cause differences at regional levels. And so it became this question of, well, where does the power lie to make those decisions? And clearly it lies in the global north. And so that scared me even more and made me start focusing more on the governance aspects rather than the pure science aspects. And what this concept that I'm describing, it really is what we can call a risk framework. Because solar geoengineering does not basically like reverse the impacts of climate change, right? We aren't going to go back to the more stable climate that we had in 1850. We are, in essence, going to create a pivot if we do this to a new climate. And that new climate will have its own risks, its own benefits, and its own unintended consequences. So how do you compare the risks of climate change with the risks of solar geoengineering in a way that is basically able to show you across regions, what actually is happening? And that would then be a much more fair, nuanced decision. If you decide to engage in it because it reduces harm, is the only reason that it should ever even be considered. But whether it does, how much it does, it's not a neat comparison because we have had work on climate change for about, I don't know, 60, 70 years at this point. That's becoming more and more granular, more and more nuanced, with many more regional understanding of regional impacts. SRM research is hardly 20 years old. Nobody really started actively. I mean, there were people who were doing some some research, but it wasn't until Paul Crutzen, who is an award Nobel Prize winning chemist, and I think simply because he was so senior and so well respected, when he wrote a seminal paper in 2006 describing what would happen if we mimicked basically those large scale volcanoes, that opened the way for other people to start asking these questions. And that research is hardly 20 years old at this point. It does not have the same level of robustness to it as climate change research has gotten to. And even climate research is still developing. Every time we're finding out more and more things. For example, the ability to now attribute certain extreme events to climate change. That's a fairly new aspect that scientists have started to delve into. How do the changes in temperature and precipitation impact GDP? How do they impact food security, certain crop yield? These are all quite new, actually. So it's not a neat comparison, but at its core, the question is, well, are the risks of worsening uncontrolled climate change more than the risks of doing SRM? Because there are risks in both directions.
Mm-hmm. And that I think is a really useful framework, because I think personally I also was more hesitant about SRM until it was put in this dimension where actually we're already within the risk of not acting because we're not acting fast enough. And I want to think a little bit more about the ways in which different communities and different groups are impacted. So you mentioned about how you want to diversify the stakeholders who are being engaged in this process because everybody brings their own perspective. So what specific groups or which stakeholders are there that we need to educate about SRM and also ask or bring to the table when we eventually discuss governance of SRM?
That's it sounds like a small question, but it's actually a really, really large question, because if you just think about it purely logically, you're like, oh, everybody should be involved in decision making on SRM. There are key stakeholders that are already involved in this process, right? So, for example, those various institutions, governments, private sector companies, universities, think tanks that are already engaged on this process is a core group. It's an ecosystem, as I like to think of it, that needs to be broadened and diversified. And the best way to do that is to go to various other places where knowledge on SRM may be limited or maybe actually zero, simply by virtue of the fact that those places have not had the bandwidth to actually engage on it. There are a lot of civil society organizations around the world. There are a lot of scientific communities around the world. There's a lot of media around the world. There are also groups that are working on other aspects other than environment and climate, such as people who push for human rights, democratic strengthening of democratic processes. Those are all people who would be impacted, or who would be impacted by climate change and solar geoengineering, and who would also be impactful in terms of changing the ecosystem and the language around SRM as well. So when we, as DSG, started, our first question was, well, where should we go and why? And it was a series of various metrics that we looked at. The first being like, well, what are climate vulnerabilities around the world, right? What's that index? Where are the risks of climate change? Where are democratic processes strong enough to actually engage in a democratic way? Where is there already some scientific work being done? And where are knowledge bases completely underwater because they are already dealing with so many other aspects of climate change? Because, well, the impacts, we don't have the ability or the bandwidth at present to have a conversation about a technology that might in 10, 20 years be actually, made available to the planet. So based on those decisions, we have tried our best to, given our limited resources, tried our best to actually go to a wide variety of places. This past year, we have gone to South Africa because there was a base of climate scientists there who are working on this issue. And we were able to engage more than 100 civil society organizations across the African continent, out of which we were able to have about 20 of them come and develop their perspectives in a South African context on solar geoengineering. We just went to India earlier this week and had another engagement exercise where we asked several civil society organizations, researchers, some government personnel, well, what are the scenarios for solar geoengineering that you would be interested in seeing? And the surprising thing is that if you look at sort of like the entertainment literature or the ethos out there, India seems to be the place that a lot of people say, oh, they might deploy because they'll get heat waves and they get floods and all these things. And then they kind of like discuss it within that framing. But you go to India and Indian people are less likely to think about it in that way. They're more interested in like, well, how does this impact the monsoon? Would be the first question that I want to ask. How does this impact heat waves? And in order to assess those aspects, you need a more Indian-focused research, a set of Indian-focused research questions in order to build a climate model or in order to build a scenario that depicts those types of answers or answers to that. Similarly, we were in Pakistan this year engaging with ComSats University, which has gotten a few different research grants looking at solar geoengineering at the South Asia level. And we also had an engagement exercise. We simulated the UN Environment Assembly for students at Air University who are doing international relations. And so that gave them a novel experience, not only of a model UN experience, but also of, well, how would discussions around solar geoengineering be between country representatives and negotiators? And that gave them insights that I don't think you would have gotten by a simple lecture or even a podcast. The actual sitting down and speaking with other representatives gave them new insights. So those are just some examples, but there are a couple more that I'd like to point to that in the upcoming year, we're looking forward to expanding our work in Africa, and we're looking forward to going to America as well, where engagement on this issue is still developing. So yeah.
And I just want to end on if you have any ideas for where the future of SRM is going to be, maybe in the next few years. Is there anything that you really hope we'll be able to achieve, or and also how you think DSG is going to play a part in creating that kind of a future, whether it be from an equity perspective or inclusion or climate justice?
That's really deep, but I will try my best to answer. It's really hard when somebody says, well, where do you think that something's going to go in the future? Because I am operating with more or less a similar amount of knowledge as everybody else. So I think there are two camps, right, that we can say are more or less polar opposites of each other. The first camp is one that says, I'm paraphrasing, but roughly that you need to do solar geoengineering because we're already out of time and this will reduce human suffering. And they're very much focused on we should do it. And then there is the other camp on the exact opposite side, we shouldn't even consider it. I think the more appropriate position is somewhere in the middle. We should assess, we should research, we should do so in a manner that is, again, inclusive, justice-oriented, transparent, and allows for a sufficiently large number of the global community to form a consensus. DSG does not advocate for a position on solar geoengineering. We advocate for the fact that these principles of climate justice should be incorporated in all activities around solar geoengineering. And so if the planet decides, or if the planet is, I think if decision makers in the planet who are empowered to make those decisions by good knowledge from a strong scientific community and a civil society community within their regions, if they decide that solar geoengineering is not a good idea and they decide that this should never be done, then they should move forward to proposing and getting approved an international treaty or agreement on a moratorium or a complete ban on solar geoengineering. And there are already processes that are starting to do exactly that. The non-use agreement, which is an academic exercise, has clearly stated several points, primarily which are no outdoor experiments, no public funding, no international assessments, no patents, things of that nature. And while international assessments, there shouldn't be any patents. And that if you are to do, if they are small scale, then they must be really well governed, and the questions asked must be really, really objectively in order to decision making. Absolutely, with the caveat that there should be responsible research to keep exploring the possibility. And if we reach a point where we clearly find out, oh, this is not a good idea at all, and here are XYZ reasons for it, then yes, a complete ban on deployment. The problem with SRM is that it is something that can be done unilaterally. It's really cheap and it's highly scalable, on the order of about tens of billions of dollars a year. Comparing that to 1.3 trillion needed, that's nothing. It's something that some very rich companies and individuals on the planet could also conceivably do. So making sure that you have good guardrails, sufficient guardrails, to ensure that research is done in a manner that is useful for making good decisions about it, and that lots of vulnerable nations and communities are engaged in those processes, that's much more critical to set up. So hopefully in the next 5 years, if a global framework can at least start to take shape, if not actually come together on solar geoengineering, and how that links to UNFCCC, that would be the ideal thing that I'd like to see. But simultaneously, we are also seeing a lot more, like the momentum has ramped up on how solar geoengineering is being engaged with currently. There is more money coming into this field. And again, considering that it's tens of billions of dollars that you would need to actually deploy per year, we just had about $200 million plus invested into the field, or at least committed towards research and governance activities just this year. So that number is likely going to keep going up. And considering that the international regulatory framework around it is weak and highly fragmented, I'm not sure whether we're going to get to that international framework that I'd like to see. But that's what DSG is also working to make sure that there is a sufficient understanding on that particular need, and that a sufficiently robust group of global community is able to get to that point. But we will see in 5 years whether or not that's the case.
Thank you so much, Hassaan. Even though it was a difficult question, I think you've given us a really good insight into the state of SRM right now and what we should look out for in the future.
Yes, and thank you so much for having me here today. This was truly a pleasure getting to talk to you.